Thank you, Jerome. Hi, everyone. My name is Christophe. I'm CTO at Guaffer. I've been working there for about 10 years now and been with the Neo4j community for a couple of more years than that. Today, I'm going to speak about locking and concurrent writing to Neo4j. So let me start sharing my screen. All right. Okay, so a bit of housekeeping in terms of how the screen will work today. So I have the Neo4j browser, which should be familiar to everybody, and there is also the terminal with two Cypher shells running next to each other. So that will actually simulate. This is why we will be able to simulate two concurrent user or application connecting and trying to write data to Neo4j. Right. So let's start first with some basics of how the Cypher shell and transactions work. Right. So when you execute a query in the Neo4j browser, for example, match and return n, it is using implicit transactions. So that means that Neo4j the driver will handle transaction for you. So you don't control the start and the end of the transaction. With the Cypher shell, you can control the aspects of the transaction. So you can manually start the transaction with the begin command to start the transaction, right? So if you go back to the browser and you list the ongoing transactions right now to the database, you can see there are two. The one that actually was my current query, show transactions, which is this one. And the second one is the Cypher shell query, right? So you can have way more information about transactions by using the yield star clause. So you can see now that you have some metadata. For example, this is the Cypher shell. This is the Neo4j browser. And the parameters of the query, start time, etc. So you have way more way more information about transactions by yielding all the columns rather than the standard columns written by default. So to stop a transaction, it is the commit phase. So this is to to close the transactions and apply all the changes that you made. Here we didn't do any changes, so we can now see that transactions is not there anymore. Right, so this is how the whole session will operate. So we will start transactions, do some work, commit transactions, and see the status in the Neo4j browser. Right, so let's start with a very familiar clause, which is merging a node to the database. So we will start a transaction and do some work, and we will not commit a transaction yet, so that we can see what is happening. So we will have now one operation that is yet to be committed in the transactions on the left. Right? So we can see show transactions, right? And we see this is this one, but we don't see any query because in the transactions you can have multiple queries. So that query is already executed, so you don't see it. So let's quickly roll back. So we actually abort the transaction. So we don't want to apply the change now. And we will use epoch to actually simulate that the query is still operating. So there is a very nice epoch function, epoch procedure to help us simulate a long running query. So which is epoch util.sleep. So if you're familiar with programming languages, this is how you pose actually your program. So what is happening here is that we start the transaction, we attempt to merge a node, and then we pause for 30 seconds so that we can actually see what is happening inside the query. So this is ongoing. It will stop by itself in 30 seconds. So we have 30 seconds to see what is happening. So now we can actually see the query that is ongoing. There is a query ID, and that query ID we can use to see the active locks. So this is locks that Neo4j takes on objects to maintain safety, right? So now we can see that multiple locks are taken by the query. So on the node and on labels and on relationship groups. We will see most of them during this session, right? So I will go back here and I will roll back, right? So right now there are still no nodes written to the database because I rolled back all the transactions, right? So the first type of operations that we will see is two transactions or two applications trying to merge a node with the same ID concurrently, right? So we will see how that works. So we will go here at this window. So in this application on the left, the Cypher shell on the left, we will start a transaction, attempt to create a node. We don't need this epoch anymore. We will attempt to merge a node with an ID, and we will not commit it. In the second shell, we actually, sorry, have to switch database, roll back. Okay, we'll start here. And here also use nodes 24 database, and this I will try to merge a node with label test, with label node with ID 1. And here I didn't start manual transaction, I just fully run it, and it created the node, which is surprising because some people think that merge actually prevents to create duplicates. It is not exactly correct, right? So if I go here and I return the node, I have one node because the transaction on the left is not committed. So if we commit it, it will be perfectly valid, and we will actually end up merge node ID 1. Yeah, so come on. Sorry. Create node ID 1. We end up with one node with ID 1. And I'm in the wrong database again. Sorry about that. Yes, now it's 24. Finally. Okay, let's do the same, but with ID 2 now. ID 2. I will open the transaction. Here, I will create a node with ID 2. It does work. We wait 30 seconds here to wait. And we commit the transaction. Now we have two nodes with the ID 2. So merge doesn't prevent duplicates. Merge works in the fact that it tries first to find if the pattern exists, and if not, it will create it. So what is happening is that in one transaction, it doesn't find anything, and it will create it. But what is created in one transaction is not visible to the other transactions, right? So in order to make that visible, we will need to have other types of locks. We will go there so that the other transactions will also have to take those locks to be able to create the nodes, right? So merge doesn't prevent duplicates. The only thing that prevents duplicates are uniqueness constraints. So we will create, we will delete everything first, merge n, detach, delete n. We'll create a constraint on the node ID property. So I will use node key, so it ensures that it exists and that it is unique. And we will run the same query. So let's go back to the shell. In the shell on the left, we will start a transaction, attempt to create a node with ID 1. And in the second transaction, we will do the same thing, but without opening explicitly the transaction. We will just do it. Now, in contrary to return immediately, it is now waiting. So what is it waiting? It is waiting that the first transaction here on the left finishes before it can actually acquire a lock in order to do its work safely, right? So once I commit, it's finished, could take the lock, verify that the node with ID 1 exists, and then had to create nothing then, right? Because that node was already existing. So only a uniqueness constraint will actually prevent duplicates, not the usage of merge on its own, right? All right, so let's see what happens when two transactions try to write a property to the same node. So let's go here. On the left, I will try to find a node with ID 1 and update the property, updated that with the date time. So I will start this transaction, and on the right, I will do the same. And it is waiting. So when you try to update properties on a node, it is acquiring a lock on the node that prevents other transactions to modify the data of the node before the lock is released, right? So transaction will acquire a lock on the node, do the work, and when it is committed, we'll release the lock so that other transaction can acquire the lock, do their work, release it. So now I have to commit it here, and it finishes. So this is when you update properties. What about changing labels of a node, right? So here I will find a node with ID 1 and add an additional label. In the other transaction, I will find the same node, but just set a property. I will not touch the label. I will just add a new property here or update the property with the new value, right? So I will start this transaction, all right? And then I will execute this one. And it is also waiting, although it is not trying to touch the label of the nodes at all. It's just trying to touch the properties. However, a lock has to be taken on the full node. The reason is that when you update labels, Neo4j has to update the statistics, the const store, etc. So you have const store for degrees of nodes, for amount of nodes, you have indexes for degrees, you have you have a lot of indexes happening, like how many nodes per label, etc. So it has to take a lock to be able to update safely the index. This is why other transactions cannot update the same nodes at the same time. So let's commit it, and now it did succeed after the lock was released. Now you will see the, why, like a use case, why those locks are taken. So let's say that in one transaction, I'm finding the node with ID 1, but in another transaction, I am attempting to update this node and set a new date time and return the node, right? So of course, this would conflict, right? So if I would return a node from this transaction here, I would actually return invalid data because that node doesn't exist anymore in the database. So it has to fail, right? So this is why locks are taken. Actually, this is to guarantee data safety and also that your results are correct. So if I commit this transaction here, you will see that it throws an error to say that unable to load node with this element ID. So the error message is just saying like this node doesn't exist, right? So your transaction has to fail. The work you're trying to do is not valid because the node doesn't exist anymore, right? So there are also some aspects, like now we have only 2 transactions, a bit of work, but what if I have more application like ETL tools, etc. So if I have this and I'm trying to, of course, I need to create the node again. Node ID.1. And let's just update the property. Okay, so if I'm now trying to here update another property, we know it will fail. But what is happening is that it's waiting that the lock from transaction 1 is released so that the transaction 2 can acquire the lock. It becomes problematic because by default, it will wait indefinitely, right? There is no timeout, right? So for that, there is a setting in Neo4j. We will see it here. Which is called DB lock acquisition timeout. So by default, it is 0, which means infinite. So we will change this this setting to be 5 seconds, for example. So let's change and restart Neo4j. Okay, wait, restart it. Let's go back to our transaction here. We'll start again. So this happened because the server was down. So I will roll back. Okay, I will do the same here. Now it has to wait 5 seconds and then stop waiting. You can see the transaction has been terminated, retry operation in the transaction, etc. So this allows you to, from your application, to fail and then retry after a failure, which is a very common pattern. All right, so we did node-to-node operation, so nodes operations trying to write to the same node. Now let's see what happens when we do write operations on a node and then try to add relationship to that node. Right? So for that, we will create some very small test data. So we'll just go here and create test nodes with ID. So we create 5 test nodes here. You can see 5 test nodes, and we will try to update a property on the node 1, and at the same time create a relationship from 1 to 3, for example. Right. So I will start with properties or labels. So we'll start with a label. So I will here open a transaction, find the node test with ID 1, and add another label. Come on. Right. So that transaction is running, and at the same time, in the other transaction, I will find the node with ID 1, find the node with ID 3, and then try to create a relationship from both, from one node to the other. And this is waiting. Again, labels lock the node, right? So that means that you will not also be able to add relationship to that node while you're adding a label, right? Because if you're trying to say, okay, find me how many relationships from this label to that label, you would need to keep track of this. So the store has to be updated. So this is why you have some blocks. So it failed. We roll back here. Now let's try to do the same, but while we're changing properties of the node. So I will open a transaction on the left, find the same node here, and on the right, I will do the same thing. But here the difference is that instead of changing a label or adding a label, I'm just changing a property. Now here, this is working immediately. So for creating relationships, you don't need, you are not impacted by the fact that another transaction is updating the properties of the node. And this is new in 5.23 with the default block format. Before it was governed by the dense node threshold, which was a Neo4j setting. So, but by default now with block format, there is not that setting anymore playing. So you can create relationship to nodes while you're updating the properties of the nodes, right? So now let's try to merge relationships from 2 different transactions from the same node, right? So here we will find test 1, test 2, and merge relationship called rel to v1 from one node to the other. So we'll start a transaction. We'll start a transaction, and in the other transaction, we will do almost the same, except from node 1 to node 3 instead of 1 to 2. And we can see here that it's actually waiting. So merging a relationship, in contrast to create, will require a lock. Actually, if you take that query and you go check the profile or the explain here, and you will see there is this operator, locking merge. So actually that will require a lock on the node to be able to merge on both nodes, actually, to be able to merge the relationship. So how to circumvent this, right? So this is a very common pattern to have two transactions that try to merge relationship from one node to the other, but the same node could be attempted in both transactions, right? So this is not very ideal. And from your application level, you really have to take care of not coming into that situation, right? So I will share a link from Neo4j, which is from here. So you just look in Google for mix and batch relationship load. So this is for partitioning. So you ensure that you have multiple partition or multiple threads, transactions that never have the same nodes in there across transaction, right? So there is a good technique. Also, you can look up with Apache Spark how that works. So I really recommend this article when you're limited to have to use merge, right? So there are two. This is how the partitioning works, right? So you have batch, 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 and it ensures that you don't have the same nodes in different transactions. Right? If you can afford to actually simulate the match and merge of the semantic of Neo4j, so let me commit this. So here, instead of using merge, I will simulate a match or create. So I will find node with ID 1, find node with ID 2. If there is no relationship rel to v3 between ID node 1 and node 2, then I create the relationship here, right? So if I use this instead and do the same in the other transaction, right? I now here start to write a relationship for 1 to 3, or if there is no relationship existing, then I will create that relationship. And you can see it returns immediately. If you go to the Neo4j browser and you check that rel to v4 from the transaction on the right has been created and already available to other transactions, while this one not, because transaction is not yet committed. So if we commit it now, we will see that rel to v3 is now created, right? So if you can afford to avoid partitioning, for example, and use match where exists or not exists and create, then it will actually allow you to much faster ingestion, actually. So we can actually test, instead of creating one relationship, we can test creating 50, right? So here, I will create 50 relationship between 1 and 2. And in the second transaction, I will create 50 relationship between 1 and 3. This one returns immediately. If I go here, I can see that I have 50 relationship. And when I'm committing that one, I will have as well 50 new relationship with v5. Right. So as a summary, if you can afford doing a match or create yourself to be able to write relationship concurrently, then it will really speed up your process. Of course, I recommend to keep the same nodes in partition if you can, but it's not. It's a lot of engineering actually. So so this is a good trick to be able to write in parallel the relationship from the same nodes actually. To summarize as well, so there is a couple of recommended links for you to read. So first is the Neo4j documentation, of course. So you have the whole concurrent data access section of the documentation. The mix and batch blog post from Eric at Neo4j. And if you fancy a book, you can register for this book. Neo4j, the Definitive Guide, was actually a more condensed version of this talk is represented as text. And that is it.